Hi guys, this is just a quick little introductory video into integration of inverse trig functions, but we're not actually going to be doing any integration just yet. What I want to talk to you about is I actually want to talk to you about the restriction of the domains and the ranges of trig functions. So typically, when we restrict the domain, when we restrict the x values, or when we restrict the angles, I should say, the independent values, we restrict them in the range from negative pi on 2 to positive pi on 2, or in other words, from negative 90 to positive 90. So if I just draw a car circle real quick, that means we'll be going back to negative 90 or negative pi on 2 just here, or we would be going around to pi on 2 or positive 90 degrees here. And when you put those values into your calculator, they will actually give you an angle that's within this particular range from negative pi on 2 to pi on 2. And if you have something that ends up being in this quadrant, well, then they'll use some of those identities and then they'll say, okay, well, actually this angle here for cos is going to be equivalent to this angle here. So we'll just give you this angle here instead. So that's how your calculators work. But that doesn't mean that you can't, are not allowed to put an angle outside of this. Remember, this whole idea of this car circle, we could travel around and around and around and around and around this circle. And I know that my angle of 0 degrees, so if I had cos of 0, is going to give me the same value as cos of 360, same value as cos of 720, and so on, same value as cos of 1080. So it doesn't actually really matter if you answer and it's not in this simple form. That's not so much of an issue in this case. What is an issue is this restriction of the range. And again, just talking about this unit circle here, I can't get a value. So let's say if I was to have this angle here of 30 degrees, this angle of 30, if I was going to do cos of 30 degrees, I could do that using my special triangles. I might write the 30 degrees up in this corner actually, because that looks a little smaller. There we go, 60 degrees. So that length there is going to be root 3, that length there is going to be 2, and that length there is going to be 1. So cos is the adjacent over the hypotenuse. So cos of 30 degrees is going to be root 3 over 2. Okay, what if we were to increase that and we were to try to find the cos of 90 degrees? Well, cos of 90 degrees is going to be equal to 0 because this is the same as the x-coordinate. If we were to keep going around, so this is outside of our realm now, cos of 180 degrees is going to be negative 1. If we keep going around, cos of 360 degrees or cos of 0 is going to be equal to positive 1. So it doesn't matter what angle that we put in, because if I put in 720 or 1080, I would still end up getting a value of 1. No matter how much my angle goes up, it's the answer, the solution is never going to go above 1. Similarly, it's never going to go below negative 1. And we can see that coming from the trig ratios. So if you think about where the trig ratios have come from, so this idea of the right angle triangle, we have our angle and we have our side that is opposite the angle, our side touching the angle, the adjacent side, and then we have our hypotenuse, which is the longest side of the triangle. So for sine and for cos, we're always dividing through by the hypotenuse. And for every single right angle triangle, the hypotenuse is the longest side or the largest side. And so no matter what values we have for the opposite side and for the adjacent side, the hypotenuse is always going to be larger. So this solution here will always end up being a fraction. Okay, so it's never going to go bigger or smaller than negative 1 and positive 1. Tan, on the other hand, is the opposite and the adjacent side. So I could have a long opposite side or I could have a long adjacent side, and that could make this value either a very small number or it could make it infinitely large. So this range of tan is actually not restricted in the general sense, because we can go from negative infinity to positive infinity. So that's just a little intro for this integration stuff, not so much because of we're integrating, but because we are looking to express our solutions in the correct way. So let's go through, let's just do a couple of simple examples from your textbook to sort of demonstrate this point. And you can put this in your calculator if you like, and you know, you don't have to believe what I'm saying. That's the really fantastic thing about maths, is that if you think that I'm talking smack about something, you can go and you can find somewhere else and you can test it out yourself. And that's the fantastic thing about science too. Okay, so let's have a look at question 1a, and this is on page 372. And what it's asking us to do, it's asking us to find the inverse sine function of 1.1. Now, as I've just mentioned, for the same reasons before, this is not actually going to have a solution because this value, this answer, this solution needs to be within the range from -1 to 1. I think 1D is asking something pretty similar. So 1D, find the inverse sine function of -6/5. And again, because this is outside of that range from -1 to +1, this is not going to have a solution either. All right, so let's have a look at something that might actually have a solution here. So looking at 1B, 1B might have a solution. Let's try 1B. So we're going to have the inverse sine of sine 5 pi over 3. Okay, so typically, I think if you didn't understand what was going on here mathematically, you would go into your calculator and you would put sine of 5 pi on 3 into your calculator and you would get some sort of value for that. And then when you put in the inverse sine, that's going to then give you that angle that would give you that value. But you've already got the angle that's going to give you that value. So the solution to this question here, because remember when we're saying inverse sine, we're asking if I've got these particular side lengths, what is the angle going to be? And when you're doing just regular sine, you're saying, okay, if this is the angle, what are the side lengths? Well, by that logic, you've kind of actually already got this angle here. So you don't even need to put this in your calculator at all. Let's do another one. I like those ones. Those ones are nice and simple. Let's do 1C. So if we did sine of the inverse of sine of 0.9, and now this one will have a solution because this is asking me what's the angle that's going to give me a value of 0.9. And then this, I would substitute in that angle to give me the side length. So this is just going to be the same thing, 0.9. Very simple. Let's do one more of those. So let's have a look at 1E. So the inverse sine of sine 7 pi over 6, and that's just going to be 7 pi over 6. Now what I should do is I should go back and I should make sure that these angles are within that domain from -pi on 2 to +pi on 2, because that would be the most simplified version, but I'm not going to stress about that too much. So what we would do if we were to actually go ahead and do that properly, I will show you one example. So 7 pi over 6, so 1 pi is going to be here, so 7 pi over 6 is going to be in this quadrant. We want it to be in either this one or this one, and because this is sine, sine is relating to the y-axis, normally sine is negative in this quadrant, so we want it to be also negative. So we would actually reflect that here, and then that would be the same as this angle here. So this would actually be -pi on 6. If we were to write that with that correct restriction from -pi on 2 to pi on 2. But again, it doesn't really make a difference. It's not going to change the value. Okay, unlike this one, it's not going to have a solution. So we do have to be more careful when we are working with things outside of the range. Okay, so a lot of your questions in your textbook are actually pretty similar to that. So I'm just going to stop this video here and I'm going to show you some derivatives using inverse sine functions, and then we'll move on, and then I will show you some integrals of some sine functions. Talk to you in the next video. See you later, guys.